In mathematics, the Routh-Hurwitz theorem gives a test to determine whether all roots of a given polynomial lie in the left half-plane. Polynomials with this property are called Hurwitz-stable. The Routh-Hurwitz theorem was proved in 1895, and it was named after Edward John Routh and Adolf Hurwitz. It is used in the Routh-Hurwitz stability criterion. Notations. Let f be a polynomial of degree n with no roots on the imaginary line. Let us define and by, respectively, the real and imaginary parts of f on the imaginary line. Furthermore, let us denote by p the number of roots of f in the left half-plane, q the number of roots of f in the right half-plane. The variation of the argument of f when y runs from -infinity to +infinity. W is the number of variations of the generalized Sturm chain obtained from and by applying the Euclidean algorithm, is the Cauchy index of the rational function R over the real line. Statement. With the notations introduced above, the Routh-Hurwitz theorem states that from the first equality we can for instance conclude that when the variation of the argument of f is positive, then f will have more roots to the left of the imaginary axis than to its right. The equality p minus q equals w minus w can be viewed as the complex counterpart of Sturm's theorem. Note the differences. In Sturm's theorem, the left member is p plus q and the w from the right member is the number of variations of a Sturm chain. Routh-Hurwitz stability criterion. We can easily determine a stability criterion using this theorem, as it is trivial that f is Hurwitz-stable if p minus q equals n. We thus obtain conditions on the coefficients of f by imposing w equals n and w equals 0.